Now, problems based on the previous, all the methods, all the cases. E power mx already we have seen. Next one sin mx cos mx. Next one e power ax into v of x or x power k models. Let us see one by one. Solve dq plus 1 into y equal to cosine 2x minus 1. Cosine 2x minus 1. Solution. dq plus 1 into y equal to cosine 2x minus 1. Equation 1 is clearly what it is, non-homogeneous. In examination you have to write this, okay? Non-homogeneous, constant quotient, constant coefficient, linear differential equation. Now what is the method to solve non-homogeneous equation? First consider homogeneous differential equation. What is that? F of d into y equal to 0. Right side function 0. That is what? dq plus 1 into y equal to 0. Equation 2. Equation 2. Now, what is auxiliary equation is? To solve homogeneous differential equation, you know the method. Auxiliary equation is f of m equal to 0. F of m equal to 0. That means mq plus 1 equal to 0. mq plus 1 equal to 0. aq plus bq formula. What is the formula? This implies a plus b into a square minus ab plus b square equal to 0. Done? So this value is m plus 1 equal to 0 or m square minus m plus 1 equal to 0. Done. This equal to m equal to -1. It is a real root. And coming to here, let us apply quadratic roots formula. Minus b plus or minus b square minus 4ac by 2a. So I'm getting this. That is, what are the roots? Therefore, roots are m equal to -1 and 1 by 2 plus or minus I into root 3 by 2. Exactly. This can be written as 1 by 2 plus or minus I into root 3 by 2. So one root is real. This is real root. This is real root. And these two are complex roots. Complex roots. Real roots and complex roots. Then what is therefore complementary function is? After getting roots, I have to write what? Complementary function is denoted by what? Yc. C dot f, complementary function C dot f, or yc equal to, for real root I have to write what? -1. Therefore minus m1x, m1 value -1. Coming to complex roots, this is the real one. This one is the real and this one is the imaginary part. For real part I have to write e power a plus or minus ib. This is a plus or minus ib. A e power ax, that is 1 by 2x, nothing but x by 2. C2, already C1 is over. For imaginary part, cosine root 3 by 2x. C3 sine root 3 by 2x. This is complementary function equation 3. Complementary function equation 3. Now, the particular integral is. What is yp formula? 1 over f of d into the right side function q of x. So I can write this one now. Yp equal to, what is f of d? dq plus 1. And what is this function of x is what? What is that? Cosine 2x minus 1, isn't it? Right? Yeah, cosine 2x minus 1. So I'm giving the process what I explained previously. 1 by f of d into cosine mx or mx plus c, same procedure. Sin mx I have already explained. The same process is for cosine mx or cosine mx plus c or sin mx plus c. sine mx plus c. What the procedure is here, 1 by f of d. F of d must contain d square terms. F of d must contain d square terms. Cosine mx plus c. Cosine mx plus c. Then replace d square by minus m square. That is the process. Replace d square by negative m square. Remember, not minus m whole square. It is m square multiplied by minus. Right? Here, what is m value? Cosine mx plus c. Here, m value is 2. So, m square is what? 4. So, replace d square by what? D square by minus m square. Nothing but minus 4. So, I'm doing that now. That is equal to, first let me write this is d into d square plus 1 cosine 2x minus 1. So this term, this function is containing d square terms. Therefore, 1 by d into minus 2 whole square, that is minus 4 plus 1 cosine 2x minus 1. Cosine 2x minus 1. So what I'm getting, 1 by 1 minus 4d I got cosine 2x minus 1. But see, what is the actual aim particular integral? I have to eliminate these d terms. Still d terms are there. So what I have to do again, but what is the function here? Cosine. So how to operate cosine? Replace d square by minus m square. But d square terms are not here. So to get d square terms, let us rationalize this. To get d square terms, let us rationalize this. This is cosine 2x minus 1. Got it? Okay, rationalize this to get d square terms to operate cosine 2x minus 1. So this is 1 plus 4d. Don't operate numerator startingly. 1 minus 16 to again what? Replace d square by minus m square. Exactly. Now what is this one? 1 by 16 4s are 64. That is 65. 65. 1 plus 4d into cosine 2x minus 1. Cosine 2x minus 1. If any doubts, you can raise the questions. 1 by 65. Now let us take this one. 1 into this. That is cosine 2x minus 1 plus 4 into derivative. D stands for what? Derivative. Derivative of cosine 2x minus 1. D stands for what? This d is nothing but d by dx. D is nothing but d by dx. So 1 by 65 cosine 2x minus 1 plus 4 into, what is cosine derivative? Minus sine 2x minus 1. And what is 2x minus 1 derivative? 2. So 1 by 65, the YP, final answer. What is the answer? Cosine 2x minus 1. This is minus 8 into sine 2x minus 1. This is equation 4. This is particular integral. Therefore, general solution of equation 1 is what? Y of x equal to complementary function plus particular integral. So y of x equal to, what is the complementary? And this is 1 by 2 now. C2 cos root 3 by 2 is there, root 3 by 2x. C3 sine root 3 by 2x, right? And coming to this, plus 1 by 65 cosine 2x minus 1 minus 8 sine 2x minus 1. Okay, that's the answer. Any doubts? The process. See, what we are doing, we are writing f of d in as a function of d squares. Then operate cosine mx plus c, replacing d square by minus m square. Then again d terms are there, but d square terms are not there. So what I have to get to operate cosine? Rationalize this and get d square terms. Then replace d square by minus m square. Then operate this numerator. Numerator 1 plus 4d. D stands for derivative. So just as usual. Any doubts? You can raise the questions. Now, next problem. Still joining. I already told you. Next question. Let me take. Yeah. Y double prime plus 4y prime plus 4y equal to 3 sin x plus 4 cosine x. Y of 0 equal to 1, y dash 0 equal to 0, y dash 0 equal to 0. Here, sine is there and cosine is there. Sine is there and cosine is there. So, solution. First, write the operator form. Operator form of given differential equation is y double dash means d square, y dash means d plus 4, y is common, equal to 3 sin x plus 4 cosine x. Equation 1. Equation 1. Now, is same as usual, is non-homogeneous differential equation, non-homogeneous constant. I will not write from the next problem onwards. This is non-homogeneous constant quotient linear differential equation. Now, consider homogeneous differential equation of equation 1, that is f of d into y equal to 0, that is d square plus 4d plus 4 into y equal to 0, equation 2. Equation 2. Now, is voice is clear and the screen is visible perfectly?
Yes, sir.
Yeah. Auxiliary equation is f of m equal to 0. That implies m square plus 4m plus 4 equal to 0. M square plus 4m plus 4 equal to 0. Now, this equal to, I think m plus 2 whole square equal to 0. Is it correct? Right. So m equal to negative 2, negative 2. So root is what? Real and repeated. What is this? Real and repeated. Repeated how many times? 2 times. Repeated 2 times. Therefore, what is yc equal to? 2 times means quotient is first degree polynomial e to the power of minus 2x. E to the power of minus 2x. Complementary function is over. Therefore, complementary function is c dot f. Now, particular integral is. Now, particular integral is yp equal to 1 by f of d into q of x. That is implies yp equal to 1 by d square plus 4d plus 4 into what? 3 sin x. One part. Another one, d square plus 4d plus 4, 4 cosine x. Split into 2 parts because sine and cosine both functions are there. That implies, now what is this one? 3 is the constant. You can write it directly over the denominator. Replace d square by what? Here, what is m? I'm giving here sine x. Here m is 1. So minus m square becomes what? Minus 1. Same logic for this. M is 1. So this is negative 1. Plus, don't replace d terms. D terms keep as it is. Sin x. Don't touch d terms. When sine is there, cosine is there. Next, 4 by minus 1 plus 4d plus 4 cosine x. Replacing d square by minus m square. So what this becomes? 3 by 3 plus 4d sin x. This is 4 by plus 4 by, what happened? 4 by 4 divided by 3 plus 4d. 3 plus 4d cosine x. 3 plus 4d cosine x. So that is equal to, now there are d terms, no d square terms are there. No d square terms are there. Therefore, I have to rationalize this by 3 minus 4d, 9 minus 16d square sin x plus 4 into 3 minus 4d by 9 minus 16d square, 9 minus 16d square cosine x, 9 minus 16d square cosine x. That is equal to, now let us operate 3 minus 4d by 9 minus 16, d square replaced by -1 sin x. 4 into 3 minus 4d by 9 minus 16 into replace d square by -1 minus m square value is that. So that is equal to 3 into, okay, now take the sin x inside. 3 sin x minus 4 derivative of sin x by 25 plus 4 into 3 cosine x minus 4 into derivative of cosine x whole by 25. So that is equal to 1 by 25 is common. 1 by 25. This is what? 9 sin x minus 12. Derivative of sin x is what? Cosine x plus 12 cosine x minus 16 cosine x derivative sin x. So this is 16 sin x. 16 sin x. So that is equal to 1 over 25. This is yp. 9 plus 16, 25 sin x, and these two gets cancelled. So this implies what is yp equal to just sin x. This is equation 4. Therefore, general solution is y of x equal to yc plus yp. What is the root? -2 now. So e to the power of -2x plus sin x. This is the answer.
Sir, we can find C1 and C2 also by boundary conditions.
Equation 5. Good. What is the given? Next, find y dash also, because derivative condition is given. So this part is C2 e to the power of -2x, C1 plus C2x into -2 into e to the power of -2x plus cosine x. Equation 6. Equation 6. Okay, now given y of 0 equal to how much? It is given as 1. That is at x equal to 0, y equal to 0, and y dash 0 equal to 0. That is at x equal to 0, y dash is equal to 0. Okay, now at x equal to 0, equation 5 implies y of 0. What is that value? Y of 0 is 1. Y of 0 is what? 1. So 1 equal to this 5. In this one, I have to put x equal to 0. C1, that's it, plus 0. So C1 value, I got 1. Next, at x equal to 0, equation 6 implies y dash 0. This part 0. And this is C2. And here I will get C1. This part 0. And I will get -2, and this is +1. Cosine 0, 1. Already C1 value is 1. So 0 equals C2. This is 1 means -2 plus 1, -1. C2 is also what? 1. Therefore, solution 5 becomes y of x equal to C1 plus C2x into e to the power of -2x plus sin x is the answer. Okay, next one. I think I have to tell equal to 0 problem. Equal to 0 problem, where I will get it. Let me create the problem. See, equal to 0. D square plus 4 into y equal to some choice is yours, whatever it is. Sine 2x I'm taking. Sine 2x. Listen, this problem, simple problem, but catch the logic. That is important. D square plus 4 into y equal to sine 2x. Equation 1. Equation 1. Homogeneous differential equation is d square plus 4 into y equal to 0. I'm giving directly, not writing all the steps. AE stands for auxiliary equation. Auxiliary equation is what? F of m equal to 0. That is m square plus 4 equal to 0. That is m equal to what? M square equal to -4. M equal to plus or minus 2i. So there is no real part. Real part is 0. Therefore, complementary function is yc equal to real part e power 0x, c1 imaginary part 2, c1 cos 2x, c2 sin 2x. That implies yc equal to c1 cosine 2x plus c2 sin 2x. Equation 3. Next, particular integral is yp equal to 1 by f of d into q of x. That is yp equal to 1 by d square plus 4 into what I have taken sine 2x. Done. Now what is this? Replace d square by minus m square. So minus 2 square, that is minus 4. If I replace that, minus 4 plus 4 sine 2x. So this part is 0. This part is 0. Therefore, what I have to write yp equal to, same logic, put 1x in numerator. Take the derivative of this d square plus 4 x into f dash d. I will write one more step, f dash d. So x into what is this becomes 2d. 2d of what? Sine 2x. Now, what is sine? This is sine 2x. What is d stands for? D stands for d by dx. 1 by d stands for integral dx. So I can write directly integral of sine 2x dx. Integral of sine 2x dx. That is x by 2. What is this? Minus cosine 2x by 2. So what is yp is nothing but minus x cosine 2x by 4. This is equation 4. Otherwise, you can do like this also. I am giving here x by 2 multiply divided by t. As in the previous problem, I told you whenever sine is there, I have to get d square term. So multiply divided by d. So what this becomes x by 2 d square means minus 4 sine 2x, derivative of sine 2x. Done. Where is the mistake? X by 2 is there. Yeah, it's right now. Here minus 4. 2x.
The derivative 2.
Yeah, 2x. Yeah, got it. Minus x by 8. Derivative of sine 2x is what? 2 cosine 2x. 2 cosine 2x. So that is equal to what? Now minus x by 4 cosine 2x. Both are same. You can proceed in any manner. So finally, what is the general solution is y equal to yc plus yp. You write this always. Okay. Combine those two solutions. Y and yc and yp. Yc and yp. Now, next, let us take the problem. Solve. Y double prime minus 4y dash plus 13y e power 18 e power 2x 18 e power 2x into sine 3x solution. What is the operator form? Y double dash stands for d square minus 4d plus 13 into y equal to 18 e power 2x sine 3x. Equation 1. What I have to consider first? Consider homogeneous differential equation. D square minus 4d plus 13 into y equal to 0. Auxiliary equation is f of m equals to 0. M square minus 4m plus 13 equal to 0. Factors no. So quadratic roots formula minus b plus or minus b square minus 4ac by 2a. So m equal to 4 plus or minus, how much this is? Yes, 36 plus or minus 6i. Correct now? By 2. That implies m equal to 2 plus or minus i3 or complex roots. Complex but not repeated. Okay, complex roots. Therefore, what is the complementary function? Therefore, complementary function is yc equal to, for real part 2 e power 2x, for imaginary part 3 c1 cosine 3x, c2 sine 3x. Equation 3. Now particular integral is p dot I. Now particular integral is yp equal to 1 by f of d into q of x. So this implies yp equal to 1 by, what is operator f of d? What is f of d? F of d is what? D square minus 4d plus 13 into what is the right side function? 18. 18 I will write in numerator, and functions I have to write here e power 2x into sine 3x. E power 2x into sine 3x. Sine 3x, that is equal to. Now, the model I told you, what is that? Yp equal to 1 by f of d. What is this structure? What is this structure? What is the structure? 1 by f of d into this e power ax into v model. What is this? E power ax into v of x model. Isn't it, right? Okay, then what is the procedure? First, take f of d on e power ax as what? By replacing d by d plus a. Replacing d by d plus a. Remember this point, e power ax into v of x model. Operate f of d on e power ax, first product of two functions, then write e power x in front and replace d by d plus a. So let us do the same thing here. 18 into e power 2x I will write in front. Replace d by what? D plus a. What is the a value? 2. A value is what? 2. So replace d by d plus 2 whole square minus 4 into d plus 2 plus 13 sine 3x. Sine 3x. Okay. That is equal to 18 into e to the power of 2x 1 by, what is this? D square plus 4d plus 4 minus 4d minus 8 plus 13 sine 3x. Sine 3x. That is equal to 18 into e to the power of 2x 1 by d square. These two terms gets cancelled, and what is this? Minus 4. Minus 4 minus 4 plus 13, how much? 9, huh? Sine 3x. Yes, minus 4 plus 13 plus 9. Now what? Let us operate. What is this model? Sine mx model. So whenever sine mx model is there, what is that? Replace d square by minus 3 square. Minus 3 square plus 9 sine 3x. So what is this becomes? This goes to 0. Then what I have to do? This 18 e to the power of 2x. Write 1x in numerator. Take the derivative of d square plus 9. That is 2d. 2d into sine 3x. So that is nothing but 18x into e to the power of 2x by 2, 1 by d of sine 3x. 1 by d stands for what? Integration. So this is 9x into e to the power of 2x, integral of sine 3x dx. Okay, 9x into e to the power of 2x minus cosine 3x by 3. That implies yp equal to how much? Minus 3x e power 2x cosine 3x. This is equation 4. Therefore, general solution is y equal to yc plus yp. You write y of x equal to, what is this value? E to the power of, what is yc? 2x. E to the power of 2x c1 cosine 3x plus c2 sine 3x minus 3x into e to the power of 2x cosine 3x. Any doubts in this problem? All of you, any doubts?
No, sir.
Clear now this model? Okay, this is the model e power ax into b model. Now let us see one more model. D square minus 1 into y equal to x sine 3x plus cosine x. X sine 3x plus cosine x. Solution. D square minus 1 into y equal to x into sine 3x plus cosine x. Equation 1. Consider homogeneous differential equation. D square minus 1 into y equal to 0. Auxiliary equation is f of m equal to 0. M square minus 1 equal to 0. M equal to plus or minus 1. Real and distinct. Therefore, complementary function is yc equal to c1 e power x plus c2 e power minus x. C2 e power minus x. Now, particular integral is yp equal to 1 by fd into q of x. This implies yp equal to 1 by d square minus 1. There are two functions here on the right side. One is x sine 3x. Another one is cosine x. Another one is cosine x. Now listen carefully. This implies yp equal to, for second case is easy. Cosine mx, replace d square by negative 1. So negative 1, negative 1, negative 2. So denominator not 0, that part is over. Coming to this one. What is the model here? What is the model? 1 yp equal to 1 by f of d into, what is the model? X into v of x. What is the model? X into v of x. I already told you, x into v of x model. Right? There are two ways we can solve. X into v of x. There are two ways we can solve. One is the formula. What is the formula? If you remember, that's okay. 1 by fd into f dash d. Okay, space is not sufficient here. Let me extend this is, what is this? Yp equal to, what is the formula? X minus 1 by f of d, you write, into f dash d. You write f dash d here only, not on the numerator position, into 1 by fd into v of x. This is the formula. Provided what? Provided when I operate this should not be 0. This denominator should not be, f of d should not be 0. That is one part. I am applying that now. Listen carefully. First, what I have to do? Formula, according to the formula, x minus 1 by f of d, f dash d, by 1 by f of d into sine 3x. V of x is what? V of x is what? Sine 3x. Plus, okay, this part is here. 1 by negative 1 into cosine x. That is equal to, same. Just by observing, you know whether this is applicable or not. See, remember this part. What is m value? 3 here. If I replace d square by minus 9, is it 0? This is not equal to 0. So I can apply this formula. For example, if here 9 is there, plus 9 is there. For example, assume. Then if I replace d square by minus 9 plus 9, 0 means this formula not applicable. Okay. Now what is this value? D square minus 1. I think you got the, you catch the logic, I hope. Now what is this? 1 by 2 I can write here. D square minus 1 d. And what is this? 1 by minus 9 minus 1 sine 3x minus cosine x by 2 minus cosine x by 2. Okay. Now this is minus 1 by 10 x minus 2 by d square minus 1 into d of what? Sine 3x cosine x by 2. Okay. This is negative 1 by 10. Take sine 3x inside. X into sine 3x minus 2 by d square minus 1 derivative of sine 3x. That is why we have written d here, not here. Minus cosine x by 2. Cosine x by 2. So negative 1 by 10 x into sine 3x minus, what is derivative of sine 3x? 3 cos 3x. So 6 cos 3x by d square minus 1. Don't write cos 3x here only. Minus cosine x by 2. Now again, what is the logic? Again, cosine mx is here. Negative 1 by 10 x into sine 3x. 6 by, what is this? Minus 9 minus 1 cosine 3x minus cosine x by 2. That is equal to x sine 3x plus 6 by 10 cosine 3x cosine x by 2. So yp is what? Minus x by 10 sine 3x plus 6 by 100 minus 6 by 100 cosine 3x minus cosine x by 2. This is 4. Okay, therefore general solution is y of x equal to yc plus yp. You write those two and that is the answer. Any doubts? Any doubts in this case? So what this formula is applicable? X into sine 3x. Okay, let me solve the same problem, this one again in a different manner. What is this? Remember, 1 by d square minus 1 x into sine 3x, or yp equal to 1 by d square minus 1 x into sine 3x, and what is this? 1 by d square minus 1 cosine x. 1 by d square minus 1 cosine x. Now see, 1 by d square minus 1. I told you one procedure also. What is that procedure? 1p equal to 1 by f of d into x power k into sin mx model. What I have written, 1 by f of d into x power k. Sin mx can be written as imaginary part of e power imx. Then this total is imaginary part of 1 by f of d into e power imx into x power k model, So let me apply that. So x into what I can write? This is imaginary part of e to the power of i3x, and this is as usual. Then this can be written as imaginary part of 1 by d square minus 1 e power i3x into x minus plus 1 by 2 cosine x. 1 by 2 cosine x. Got it? Now what is the model this one? What is the model this part? E power ax into v of x model. E power ax into v of x model. What I have to do? Imaginary part of 1 by, first I have to operate e power ax. How to operate? Replace d by d plus a. That is, a value is what? 3i. Plus 1 by 2 cosine x. Replace d by d plus a. That is d plus 3i. Okay. So you must thorough with the rules. That is very important. E power i3x 1 by d square minus 9 plus 6 di minus 1 into x cosine x by 2. I hope this is clear. Now the challenging, another one. What is this? E to the power of 3ix 1 by d square plus 6 di minus 10 into x plus cosine x by 2. Now what is the challenging one? I have to evaluate this. Done? Okay. So what is the procedure I'm giving? Again, I'm explaining. This is 1 by f of d into x power k model. So how to evaluate this? First express this as 1 plus phi of d into x power k. Take this 1 plus phi of d to the numerator, whole power minus 1 x to the power of k. Then expansion. Okay. So let us do same thing. And to get the form 1 plus phi of d, to get this form 1 plus phi of d, I have to take least degree term common. Least degree term means what? This minus 10 is the least degree term. So e to the power of 3ix by negative 10 is common. Then what this becomes 1 by 1 minus d square plus 6di by 10. Is it correct? Into x. This is over plus cosine x by 2 is there. Definitely you practice this problem at home once again. Imaginary part of this is negative e to the power of 3ix by 10. And what is this is, take this one into numerator. That is 1 minus d square plus 6di by 10. Okay. This whole power minus 1 into x. This is over plus cosine x by 2. And what is the formula here? I'm giving 1 minus x whole power minus 1 formula. 1 plus x square plus x cube and so on. Here, what is this x? This x is what? This part. 1 minus. This is in the format 1 minus x whole power minus 1 formula. Okay. So, if I expand that, up to what term I have to take expansion, that is important. See, what is this one? This one, d stands for derivative. And this is function x only. For x, how many derivatives exist? Only first derivative exists. Second, third derivatives are zero. So expansion is required up to first derivative. That's enough. So what is this? 1 minus x whole power minus 1. That is 1 plus x. What is x value? What is x value? This one is x value. And no need of remaining terms. Why? Because those are contains d square terms and so on into x. This part is over. So whatever the required terms are there, you write those terms. Now this is equal to imaginary part of e to the power of minus 3ix by 10. Now take x inside. X plus 1 by 10 d square plus 6di into x. That's it. Remaining parts are zeros. Plus cosine x by 2. If any doubts, I can repeat. You can ask. Imaginary part of minus e to the power of 3ix by 10 and this is x plus 1 by 10. D square of x is what? 0. D of x is what? 1. So 6i. That's it. Plus cosine x by 2. Cosine x by 2. That is imaginary part of. Now take minus 1 by 10 inside. Minus x by 10 minus 6i by 100 plus cosine x by 10. All cosine x by always, but remember, I have to select imaginary part. Therefore, keep this e power 3x outside and whatever the term is there, take inside. Whatever the term is there, take inside. Okay. Now, what is meant by e power 3x? What is the e power 3x? Cosine 3x plus I sine 3x multiplied by what? Minus x by 10 minus 6i by 100 plus cosine x by 2. Now, in this product, I have to select, in this product, this into this, a plus ib into c plus id, I have to select only imaginary part. Imaginary part means what? Which contains items. Which contains items. So, which term contain item? This into this. So, minus 6 cosine 3x by 100. Imaginary part. Another one is this. Minus x by 10 into sine 3x. Okay, that's it. Plus cosine x by 2. This is yp. That's it. Is both are same? Both are same. Whatever we did with other formula. Yeah. Minus x by 10 sine 3x minus 6 by 100. Here I got minus y. Some mistake I did. This is plus cosine x. Okay. This is plus cosine x. Then I have taken minus maybe. Now this is plus. This is plus means this becomes minus. This is minus. All of you remember this procedure. Second procedure is very important because many of the problems are solvable by this procedure only, imaginary part and real part. Remember. Any doubts? Yes, any doubts?
No, sir.
No, then you try. Solve d square. Let me give, wait. Yeah, d square minus 6d. Already we have solved this. Right. D square plus 2d plus 5. D square plus 2d plus 5 into y equal to e power minus x into cosine 2x. Cosine 2x. Next one, 8d square minus 12d plus 5 into y equal to 16 sine x. 16 sine x. That is okay, sine, no problem. dq plus 3d square, dq plus 3d dq, where it is, dq minus 3d square, dq minus 3d square plus d minus 3 into y equal to 6 cosine x, and dq minus 4d square plus 9d minus 10 into y equal to 24 e to the power of x sine 2x. X into v we need, no? Yeah, one problem. X into v, d square minus 5d plus 6. D square minus 5d plus 6 into y equal to x into cosine 2x. And sixth one, d square plus d minus 2 into y equal to x square into sine x. X square into sine x. Anyway, tomorrow I will spend one more class based on all these cases. Which model is not covered now? I think almost all covered, but I will tell more number of problems, okay, to get perfection in this topic. Any doubts? Okay, till 10 minutes are there now. Let me solve this last problem. See, all of you, sixth problem. Firstly, d square plus d minus 2 into y equal to x square into sine x, equation 1. Homogeneous differential equation, d square plus d minus 2 into y equal to 0. Auxiliary equation is what? Auxiliary equation is m square plus m minus 2 equal to 0. What are the roots? Plus 2, minus 2, 1. Is it correct? 2m, right. Therefore, what is y? Say c1 e to the power of minus 2x, c2 e to the power of x. Coming to yp. Yp is what? 1 by d square plus d minus 2 into x square into what? Sin x. Now, what is the model? This is, model is what? Yp equal to 1 by f of d into x power k into sin mx model. X power k into sin mx. Okay. Okay. Let me change. This is assignment. This is assignment. I will solve cosine. I will solve cosine. Already sine one problem is solved now. This is cosine. So x into v formula not applicable. X into v means x power must be 1 only. Now here 2. So there is no other chance. I have to convert this to what? Real part of e power ix. E power ix means cosine x plus I sin x. So real part. Now take real part front side. Real part of 1 by d square plus d minus 2 e to the power of ix into x square. Okay. That is real part of operate now e power ix. How to operate this is replace d by d plus a. A value is what? A value is what? I. So d plus I whole square, d plus I minus 2 into x square. That is real part of e to the power of ix 1 by d square plus 2di minus 1 plus d plus I minus 2 into x square. This is real part of e to the power of ix 1 by d square. Now take d terms, club d terms. These two are d terms. What is the common then? 2i plus 1 is common, d. Next one is what? Minus 3. You write I minus 3, correct? X square. Any corrections? Sorry, minus 1, correct. Plus d plus I, correct. Minus 2, right? D square, d term common, 2i plus 1 is there. Next constant term is I minus 3. Constant term is what? I minus 3. Now, this is real part of e to the power of ix. What I told, this is, what is the model? Yp equal to 1 by f of d into x power k model. So I have to write this is 1 plus phi of d model. 1 plus phi of d. To get 1 plus phi of d, I have to take 1 plus phi of d, I have to take least degree term common. That is what the term? I minus 3 term common. So 1 by 1 plus d square 2i plus 1 by I minus 3 d. Sorry, wait. Whole by. This is d. Whole by I minus 3. This is into x square. So this is equal to real part of e to the power of ix. Let us rationalize this. I plus 3 by, what is this? Negative 1, negative 9. And take this one to numerator. 1 plus d square plus 2i plus 1 into d whole by I minus 3. This whole power minus 1 x square. Jartha vinandi ikkada. This step is very important. Real part of e to the power of ix minus 10 I plus 3. What is the expansion? 1 plus, this is 1 plus this total is x. This total is x. 1 plus x whole power minus 1 expansion. 1 minus x plus x square minus x cube plus x power 4 and so on. Okay. Now 1, first writing I am 1 minus x. Minus x means this term. D square 2i plus 1 into d by I minus 3 1 plus x. Now x square is needed. What is this function? X square. For x square, how many derivatives exist? D of x square is 2x. D square of x square is what? 2. And d cube of x square is what? 0. So up to second derivative required. So I need one more term, because d square 2i plus 1 into d by I minus 3, this one whole square. In this one, this d square will be there. Here, d whole square, it will be there. Into x square, this bracket closed. Now, remaining terms are negligible. Real part of minus e to the power of ix, I plus 3 by 10, take x square inside, plus 1 by I minus 3. What is d square of x square? 2i plus 1 into d of x square. This is over. Okay, this is minus, no, sorry. This is minus. And next plus. And remember, all of you, in this one, which term is required? Only b square term is required. Only b square term. A plus b whole square, b square term is required. That is why I am writing that only. What is that? 2i plus 1 whole square d square of x square by I minus 3 whole square. Remaining terms are zeros. Remaining terms are zeros. Now you can simplify this. Now you can simplify this. Real part of minus e to the power of ix, I plus 3 by 10. This is x square minus 1 by or I plus 3 by negative 10. I plus 3 by negative 10, rationalizing that. And what is this? D square of x square is 2. And that is 2x. 2x into 2i plus 1. This is over. Next, plus. Coming to this, what I will get? Minus 4. A plus b whole square. What you will get? Minus 4 plus 1. Minus 3. Plus 4i. Yeah, a plus b whole square. By I minus 3 whole square. This is 2. Okay, I'm giving assignment for this. Later on you do yp. And what how to write yp? E power. Just keep our ix outside and remaining every term inside. Then write this as real part of cosine x plus I sin x multiplied by this. And in this one you select only real parts. In this one you select only real parts. That is the answer. Okay, you can do this. Simple manipulation calculations are there. Okay, but only the complication is here. Just don't keep items in denominator, keep them in numerator. So here also you rationalize by I plus 3. Okay, I will stop here. Any doubts? Any doubts?